Okay, so in today's video we're going to have a look at quadratic, cubic and reciprocal graphs, and we're going to have a look at these types of questions at the end here where you have to match these line equations or graph equations onto the corresponding graphs that are shown to you. These questions do tend to throw quite a lot of people, but in order to be able to answer these sorts of questions you have to have a really good understanding of what the graphs look like, how to plot them and why they create the shapes that they do within the graphs. So we're going to have a look at all of those different graphs separately. We're going to start off with quadratics, then we're going to have a look at cubics, and then we're going to have a look at reciprocals, and then we're going to have a look at applying it to these types of questions that I've got shown on the screen right now. So what I'll do is I'll link all the slides in the description below so you can print these off and draw them if you like, and also I will timestamp all of the different equations in the comments, so that if you want to just go to quadratics you can go jump to that, if you want to go to cubics you can jump to that, and reciprocals you can always jump to that, or if you want to just go straight to these matching graphs equations then you can always jump to that as well. But I would say to stick through them all and have a look at going through all of these just to make sure that you're happy with all these different types of graphs. So we're going to get started with quadratics, and here's the first question we're going to have a look at. Okay, so our first question, we are starting with a quadratic. Now we know that a graph is a quadratic if it has a little squared in it. So this particular graph has x squared, and this is quite a nice one, it's just x squared take away 4. Now normally you're asked to complete a table and then also draw the graph. Now my main priority for this video is going to be on actually getting these tables completed. I like to hope that we can all draw these graphs once we've got the coordinates. So I'm not going to stress too much about the actual drawing here. In fact, the actual graphs that I've got on the screen are quite small and mine aren't going to be perfect, but I'm just going to give you the general idea of how to go about drawing all these graphs here. So for this one here we've got y is equal to x squared take away 4. Now that obviously means just to find the y coordinate we square the x coordinate and then take away 4. So it's hopefully quite nice and simple. We're going to have a look at a trickier one after this where you just got to be careful with how you actually go about doing this. So it says for all the values of x from -3 to 3. Now if it doesn't give you that information you can find them along the x-axis here. If you have a look, the x values stretch along from -3 along to 3 there. So that's where we get them if it doesn't tell us, okay, or if we're not given a table. But for all of these I am going to give you a table. Now obviously we are starting with this one on the left, so we've got -3 there, and we need to sub that into our equation. So to find y, I'm just going to write the working out. We would do x squared, so -3 squared, and we've got to be very careful when we're writing -3 squared, because particularly if this is a calculator question, if you type that into the calculator you are going to get the answer -9, because what the calculator does is it squares the 3 and then puts the minus with it. It doesn't actually do -3 squared. So a really important little thing that you need to remember throughout this is that we're just going to put all our numbers in brackets like that. Okay, so we're going to -3 in brackets squared, and then we're going to take away 4. Of course, if this is non-calculator we can work that out anyway, because we can do -3 squared, which is +9. So we've got 9 take away 4, and that gives us the answer 5. So we know that that number there is going to be 5. We can then move on to the 0, and again I'm not going to write all the working out down for every single one here, but we would just do 0 squared, again we'll put the 0 in brackets although it doesn't matter if the number's not negative, and then take away 4, and 0 squared take away 4 is -4. So we can just put -4 straight in there, and the rest on this next one here I'm going to do without writing the working out down. We've got 1 squared, which is 1, take away 4, which is -3. Now it's not that easy to spot, but obviously when it comes to straight line equations there's always quite a nice pattern in the table. When it comes to quadratics there's not the nicest of patterns, okay, and the others aren't going to follow a pattern, but there is actually a bit of a pattern in a quadratic. If you have a look, we've got -4 in the middle, and either side of that we've got -3, either side of that we've got 0, and either side of them we've got 5. So there is a bit of a pattern, although I certainly wouldn't rely on these because they don't stay there throughout all of the graphs, and sometimes it's very difficult to spot some of these patterns. But just thinking about the fact that there is a bit of a pattern when we're looking at these. So let's have a look then. Actually plotting this on the graph, now we've got an x and a y coordinate there, that little bit there, x is -3, y is 5, so that's the coordinate -3, 5. Now I'm going to plot these quite quickly. -3, 5 is somewhere up here. I'm not going to be able to do them perfectly on the screen here. Then we've got -2, 0. We've got -1 to -3, obviously getting your x and y coordinates the right way around here. 0 to -4, and then it repeats the pattern going up the other side there. So we've got 1 and -3, we've got 2 and 0, and we've got 3 and 5, which is somewhere up there. Right, so in terms of actually drawing the graph here, we've plotted the points. We now need to get a nice smooth curve that goes through all of the points. So not with a ruler, a nice smooth curve, and it has to go through every single point. So I doubt I'm going to get this perfect. I'm going to give it my best shot. I'm just going to do a nice smooth curve Ooh, no little kinks in it. I actually can't see them as I'm doing them. There we go. So I've done it as best as I can, but you want to get yours nice and smooth. Okay, so make sure you do it with a pencil, rub it out if you have any kinks like I've got down the bottom there, but then you can go back and have a go and actually rub it out and just make sure you get a nice smooth curve there. Right, so that's what a quadratic graph looks like. We're going to have a look at a slightly harder one. Before we move on there are a couple of things to know about this quadratic graph and a couple of the points that are important. We're not going to look at them specifically in this video, but there are two places which are, well, technically three, but there are two things that are quite important with a quadratic graph. One of them is this point right here at the bottom where it sort of stops going down and starts going up. That can be called a couple of different things. It's got a specific coordinate there. It's 0, -4. It can be called the turning point. There we go. Or it could be called the minimum point or the maximum point if it's sloping another way. So the minimum point or turning point. There we go, the turning or the minimum point, that's a very key place on a quadratic graph. And there's also two other points here, which is where it crosses the x-axis. So we've got these 2 points there, which is -2 and 2. Let's just write that in there, -2 and 2. And these have a special name as well. They've got two names again. They can be called the roots. There we go. Or they can be called the solutions. There we go. Roots or solutions. So we're not going to focus on those points in this particular video, but obviously just a couple of extra little bits to be thinking about there. The roots and the solutions where it crosses through the x-axis, and the turning or minimum point down the bottom. Obviously just adding a little bit of context to the language there. The turning or the minimum point seems like quite an obvious place, so you would just give that as a coordinate 0, 4. But then the roots, okay, doesn't always necessarily have a bit of a logic there, but I do like to think of this x-axis as being ground level. And when you think about plants and things like that, where they meet the ground is where the root starts. So I do like to think of these sort of things as like the little roots there, and that's sort of where the word comes from. But you've also got the word solutions, so there's not really any context there, but it's just where it meets the x-axis there. Right, so let's have a look at a slightly trickier one before you have a go. Okay, so this question here is slightly trickier. Our equation is y equals x squared minus 5x plus 3, and we've got the values from -1 to 5. Now it's that -1 there that we're going to make a mistake on if we do make a mistake, so we've just got to be extra careful with that. So thinking about our little brackets, we're going to put -1 in a bracket, and that's going to be squared. Take away, well then we've got 5 lots of another x, so another -1 goes in there, and then we're going to add 3. I'm just going to be really careful with your numbers here as you go about working this out. -1 squared is -1 times -1, which gives us +1 or +1. Then we've got -5 times -1, and that gives us +5, so you've just got to be careful there when you do this. And then we're going to add 3. So actually when you're looking at the sum's not too bad, but that little bit there, that -5, -1, just got to be very careful. If you do 5 times -1 and get the -5, you just got to remember you're actually taking away that -5, and take away -5 gives us the +5 that we've got below there. So 1 + 5 is 6, plus 3 is 9. So there we go, that's our value in there, 9. Then we can go about working out the others. The others aren't so bad because without those negatives, we've got 2 squared. And again, I'll write the working out down for this last one. 2 squared, take away 5 lots of 2. There you go, putting the 2 in again, and then adding 3. So 2 squared is 4. Then we're going to take away 10, it's -5 times 2, so take away 10, and then add 3. And that leaves us with 9. 4 take away 10 is -6, 4 take away 10 is -6, add 3, I don't know what I was saying there. That is going to leave us not with 9. 4 take away 10 is -6, add the 3 is -3. There we go, so we get -3 there. And then our last value, I better write this down after I just said that. Let's go for this, we've got 4 squared, take away 5 lots of 4, which is 20, and then +3. So let's get rid of that 4 squared, let's write 16. So we've got 16, take away 20, which is -4, add the 3 is -1. And again, you can see a little bit of a pattern. Look, we've got 2 -3s in the middle, then a -1 either side, a 3 either side of that, and we've got the extra 9 going on at the end there. Let's get rid of those and let's plot this on the graph. So we've got -1 to 9, which is there, 0 to 3, there, 1 to -1, as best I can there, and always look out for the scale on these. If you can see on this one, the y-axis scale, the numbers are a bit closer than on the x-axis, so do watch out for that. 2 - 3 is down here, I can just about get that. 3 - 3 is there, 4 minus 1 is here, and then we've got 5, 3, which is there. And again, a nice smooth curve using a pencil as best you can, making sure it goes through all the points. There we go, I've just about managed to get that. This one here, I would say that one's not very good there. It does need to make sure it's perfectly going through the point. But there we go, that gives you the general idea of how to go about actually drawing these quadratic graphs, and now here's one for you to have a go at. Okay, so here's a question for you to have a go at. So pause the video there, have a go, fill in the table. If you haven't got it printed off, don't worry too much about drawing it. You can just imagine where the points are and actually just maybe trace it with your finger and see if you can actually figure out where they go. But pause the video there, have a go, and we'll go over the answers in a sec. Okay, so for this one here, we've got x squared minus 3x plus 1. So this one here is not a very nice one. We've got negative 1 squared, take away 3 lots of minus 1, and then add 1. So let's work this out. We've got 1 and then plus 3. When we do minus 3 times minus 1 plus the 1. So 1 plus 3 is 4, plus 1 is 5. There we go, so that one there is 5. On the other side of that, we've got to do this one here. So we've got 2 squared, which is 4, take away 6, which is minus 2, and then add the 1, which is minus 1. Okay, and on to the 4, we've got 4 squared, which is 16, take away 12, 3 lots of 4, so 16 take away 12 is 4, add the 1 gives us 5. There we go, and that matches obviously with our little pattern there. We've got the minus 1s in the middle, then the 1s, then the 5s, and that 11 sitting at the end. So plotting this, we've got negative 2 to 11, which is up here. We've got negative 1 to 5, which is there, 0 to 1, 1 to minus 1, we've got 2 to minus 1 as well, there we go, 3 to 1, and 4 to 5, and again, a nice smooth curve, getting through all the points, there we go. Right, there we go, I did actually miss one here, so I would need to rub that out and just correct that, make it a little bit more perfect, but there we go, you get the general idea. Okay, so before we move on, I've got one more for you to have a look at that's just going to form a slightly different looking quadratic graph. It's an important one for you to see, so do check this one out and have a go at this one and see what you get, and I'll show you what it is now. Okay, so this one is slightly different. If you have a look, we've got 4 take away x squared. So I would encourage you to just have a go and see what you get, see what it looks like. Okay, so pause the video there, have a go, and we'll go over the answers in a sec. Right, okay, so putting these numbers in then, the first one we've got to put minus 2 in, so we've got 4 take away, and then we've got minus 2 squared. So that's 4 take away, negative 2 squared is 4, and 4 take 4 is 0. There we go, so we get 0 in there. Then for the next one, we've got 4 take away 0 squared, well 4 take away 0 is 4, so that's going to be our 4. Then we've got 4 take away 1 squared, 4 take away 1 is 3. And then for the last one, then we've got 4 take away 3 squared. 3 squared is 9, so 4 take 9 is minus 5. Again, there is a bit of a pattern in this one, so hopefully you can spot that. We've got the 4 in the middle, 3's either side of it, 0's either side of that, and negatives 5's either side of that. So we've got negative 3, negative 5, which is a bit bizarre because that's obviously starting down here. Some of our others have started at the top. Negative 2, 0. Negative 1, 3 is there. 0, 4 is here, 1, 3, 2, 0, and then 3, negative 5, which is down here. And there you go, you can see when you join this up, look, you get this upside down U shape, there we go, which obviously forms a different looking quadratic. Now a quadratic obviously is formed like this when we have this minus x squared, okay, so it's almost like just an upside down, a reverse of the other x squares that we've looked at. Okay, it's just flipped upside down. So this is that scenario where, well, like I mentioned at the start, look, rather than being called a minimum point, this coordinate here, 0, 4, would be called the maximum point this time. There you go, as it is at the top of the graph rather than at the bottom. Okay, so just something else to be thinking about there that can come up, obviously looking at the coordinates of the minimum or the maximum point, okay? Right, so let's have a look at some cubic graphs. Right, okay, so I'm only going to do one of these cubic graphs because the process is pretty much the same. We just need to think about what they look like. Now, a standard x cubed graph, if I try and draw it as best as I can, has this sort of shape. Okay, not perfect there with the numbers, but it has this sort of shape. It crosses through the origin and it has this sort of wiggly line shape, and we'll look at why it's made. But that one there is what x cubed looks like. It just crosses through the axes just on 0, and that is going to come up later in the video when we're looking at just these x cubed graphs. But we're going to have a look at obviously what they look like when we've got a little bit more than just x cubed within there. So obviously this question has x cubed minus 3x plus 1, and all we're going to do is put the values into the equation just like we have done before. So for negative 2 that we're going to put in, we've got negative 2 that's getting cubed. Then we've got take away 3 lots of that negative 2, and then we're going to add 1. And when you cube a negative, it does stay negative, so it's just like doing 2 cubed, but it's going to be minus 8 this time. 2 times 2 times 2, but it's negative 2 times negative 2, which makes positive 4, times it by another negative 2 makes negative 8. Then we've got the negative 3 times the negative 2, got to be careful there, so that's going to make plus 6, because we've got a negative times a negative, and then add the 1. So minus 8 plus 6 is minus 2, add the 1 is minus 1. So there we are, there's our first coordinate, minus 1. On to our next one. We've got 0 to put in, that's quite nice. 0 cubed is 0, take away 3 lots of 0 is still 0, add the 1, gives us 1, that's a nice quick one. And then for the last one there, we've got 1 cubed, take away 3 lots of 1, so 1 cubed is 1, take away 3 is minus 2, and then add the 1 is minus 1. Okay, so we need to go about actually plotting these points on, and there's not really much of a pattern there. You might be able to spot something, but let's just get it on and see what it looks like. So negative 2, negative 1 is here, negative 1, 3 is here, 0, 1 is here, 1 to minus 1 is, let's have a look, 1 minus 1 is there, and then 2 to 3 is here. There we go. So that looks very bizarre when you're actually plotting this on, but remember it has this sort of wiggly sort of curve that I showed you before, but this one is just a little bit more stretched out. Let's have a look. We've got coming up there, down to here, and up to there. There we go. And that is our sort of cubic graph and what it actually looks like. Obviously these lines would actually continue here. Okay, and we'd sort of get the same sort of shape that I've got there, but just a bit more of a kink in the middle there. Okay, so obviously don't extend past those points, but that's what our cubic graph is going to look like. Okay, so what we do find is when we don't just have x cubed, it has more points where it crosses through the x-axis. So obviously we've got 1 here, 1 there, and 1 there, so we can have a potential of obviously up to 3 points going through there as well. Okay, so a lot of these cubic graphs do have this slightly bigger wiggle that sort of crosses through the x-axis a few more times, but if it doesn't have any sort of additional elements going on with the x cubed, it does just cross through at the origin there. Okay, but that is our cubic graph, and let's have a look at one that you can have a go at. Okay, so I've got a couple for you to have a go at, so here's your first one, so pause the video there, have a go, and we'll go over the answers in a sec. Right, so drawing the table then, we've got minus 2 to put in first. So let's put that in. We've got minus 2 cubed, just following our equation up there. Take away 6 lots of minus 2, and then we're adding 4 at the end. Negative 2 cubed is negative 8. Negative 6 times negative 2 is going to make plus 12, and then we're going to add 4. Negative 8 plus 12 is 4. Add the 4 gives us 8. There we go, so negative 2 gives us a value of 8. Then we've got 0, 0 cubed, take away 6 lots of 0, add 4, just gives us 4. We've got 1 cubed, which is 1, take away 6 lots of 1, so that's minus 5, add the 4 is minus 1, and we haven't actually got any more values to plot there. Just as a little side note, which is quite nice, this number at the end, just like with linear graphs, is our y-intercept. So when you're doing the 0 one, you can actually just get that nice and quick look because it just matches. If you sub-0, and you're always going to get that number at the end there. So just thinking about that in terms of the y-intercept of the graph and where it's going to cross through the y-axis. But let's plot this on, see what we get. So negative 3 to negative 5 is down here. Negative 2 to 8 is up there. Negative 1 to 9 is, let's have a think, there we go, in between 8 and 10. 0 to 4 is here. 1 to minus 1, as best I can, is there. 2 to 0 is here. And 3 to 13 is up there. Right, there we go. So we've got quite a big bendy graph here. Let's have a look as best I can. Oh, there we go. Right, so there we go. There's our cubic again. Obviously a massive wiggle in the graph there, but there we go. There's just another cubic for you, and obviously just making sure that you draw that with a nice smooth curve. Let's have a look at one more before we move on. Right, okay, so one last one for you to have a go at before we move on to reciprocal graphs. Again, you could always move on if you want, the timestamps are in the description, but let's get started and pause the video there and we'll go over the answer in a sec. Right, okay, so we've got x cubed plus 2x minus 1. So for this one here, we've got negative 2 cubed plus 2 lots of negative 2 and then minus 1. And if we do that, we've got minus 8 plus 2 lots of minus 2 is minus 4, so rather than putting plus minus 4, let's just put minus 4, and then take away 1. Minus 8 take away 4 is minus 12, take away another 1 is negative 13 as our final answer there, negative 13. Then for the next one, we've got 0 cubed, which is 0, plus 2 lots of 0, and again, actually, look, let's just apply a little trick. That minus 1 at the end is in our 0 box. All right, the next one, 1 cubed is 1, plus 2 lots of 1, so 1 plus 2 is 3, take away the 1 is 2. And let's plot all these points on and see what this one looks like. So negative 2 to negative 13 is there. Negative 1 to negative 4 is here. 0 to minus 1 is there. 1 to 2 is here. And 2 to 11 is up here. Now this isn't the nicest of ones actually, because, and if I have a look, there are lots of different ways that you could probably think about drawing this. We probably could just do that, okay, and that would obviously look absolutely fine, or we could actually probably go about maybe sort of doing something like that, and that would obviously be fine as well. Now obviously we are just drawing this as best as we can. We don't know exactly what it's going to look like unless we plot a lot more points, so it's up to you in terms of how you go about making that. I would probably just go with a nice smooth curve like that, and that would be absolutely fine for me. Okay, so that's absolutely fine to draw your graph like that. Obviously you can go onto some graphing calculators and draw these on the computer just to make sure you check what they actually look like, but you don't need to stress too much about that wiggle there and making sure it's absolutely perfect, as long as you get a nice smooth curve for all these points and you know the general look of what these graphs look like. But there we go, that's cubics. We're going to move on to reciprocals now, so let's have a look at one of those. Okay, so a reciprocal graph, there we go. So we've got our line equation here, it's y equals 4 over x. So this is what forms a reciprocal graph. This is when you've got a number getting divided by the x there, and it forms a particularly different looking graph as well. So this is called reciprocal, and let's just have a go at filling these numbers in the tables and seeing what we get. Now I actually think these are probably one of the easiest ones to plot, but they do normally tend to just throw people a little bit, particularly if they haven't seen one. So let's just have a think about what this actually makes here. So we've got 4 divided by x, so we've got 4 divided by 0.5, and there we go. Obviously if you don't have a calculator here, there's a couple of little tricks you can do to figure that out, but dividing by a half just doubles the number. If you think about logically, what a half fits into 1 twice, it doubles the 1, it makes the 1 2. So if we do 4 divided by a half, we get 8, and again you can check that on the calculator, but it just doubles the number there. The next one along, we've got 4 divided by 4 here, and 4 divided by 4 is 1. Here we've got 4 divided by 5, not very nice. 4 divided by 5 is 4/5, 1/5 is 0.2, so that's 0.8. It is quite most likely you would have this using a calculator, but obviously just quite a nice one if we didn't have a calculator, and thinking about how we'd approach that. And the last one here, we've got 4 over 8. 4 over 8 simplifies as a fraction, it's 1/2, so writing that as a decimal, 0.5. There we go. So we've got some slightly different values here. You'll see it starts off at 8 and it gets smaller and smaller and smaller as we sort of increase the number there. And obviously think about the logic behind why that happens. We've got 4 dividing by a number. If we divide that by a small number like 0.5, we get a large answer. Divide it by a big number, obviously, or just an increasing number, that's going to make our answer smaller and smaller. So if we actually go about plotting this, we've got 0.5 down the bottom all the way up to 8. That is there. We've got 1 that goes to 4. We've got 2 that goes to 2. 3 goes to, we don't have 3, so we can't do that. 4 to 1. 5 we've got 0.8. I'm trying to do this as best as I can. 4 little squares up. And then we've got 8, which is 0.5, and that's there. Right, so joining this up, what we get is, and I'll try and do this as best as I can, a nice smooth curve again. We just get this sort of, there we go. There we are. And we get that is what a reciprocal graph looks like. Now what we don't have is a full 4-quadrant graph here, but if we did, our bit that we've drawn would go in here, And if we actually looked at the negative element of this graph, so subbing in some of the negatives, like if you imagine we put minus 0.5 in, minus 0.5 would give us minus 8, which would be down here, and the rest of the graph would then form that same pattern going this way. There we go. There we are. So obviously it's not asked us to draw that negative part for this particular graph here, and it very rarely actually does, because it's actually quite complicated obviously to have a 4-quadrant graph and draw all of those elements. But there's something a bit strange that happens in a reciprocal graph. Obviously we've got two different lines there. We've got the positive element over here, which we've drawn on our graph, and you can also have the negative element over here, but they don't actually join up. And if you think about the logic there, that's because if we put this point here in the origin, we would end up with 4 divided by 0, and dividing by 0 is obviously an impossibility in maths. We can't actually divide by 0, it doesn't make any sense, so we can't actually do that. We can't actually get a value for 0, and because of that it sort of jumps away from the origin and actually never touches the axes there. You think no matter what number we put in, we're never going to get a value of 0. We can keep making 0 smaller and smaller and smaller, but we'll just get a bigger answer for y. We can keep making x larger and larger, but again we'll just get a smaller value of y. It will never actually hit 0. So these sorts of graphs here never actually touch the axes, but there we go. That's what sort of defines just a little bit to do with this graph here, so you understand why it looks the way it looks. Okay, so here's one for you to have a go at, drawing a reciprocal graph. Okay, so pause the video there, have a go at plotting these numbers or just getting a table filled in and thinking about what the graph would look like. Obviously, if you've got it printed out, then you can go along and draw it as well. But there we go, pause the video and we'll go with the answer in a sec. Okay, so for this first one then, we've got 6 divided by x, so 6 divided by 0.5 for the first one. Again, divided by a half doubles your answer, so we get 12. 6 divided by 3 for that next one along there is 2. 6 divided by 5, not the nicest one, let's have a look. 6 over 5 is a mixed number, is 1 1/5 or 1.2. And that's our last little box there. Okay, that was quite nice actually, just filling in those numbers. So let's go about drawing this. We've got 0.5 that goes all the way up to 12, which is right at the top there. 1 to 6, which is here. We've got 2 to 3, which is there. We've got 3 to 2, there, 4 to 1.5 as best I can, there we go, 5 to 1.2 again as best as I can, just slightly above the 1, and then 6 to 1, which is there, and again joining that up with a nice smooth curve, and there we go, there is our reciprocal graph drawn. Okay, so next thing we're going to have a look at is matching some graphs to some equations. So think about obviously all these equations. We've obviously already looked at straight line graphs in previous videos. Obviously we know what they look like, they're just a straight line and they're equations. But we've obviously looked at quadratics, cubics and reciprocals in this graph, and we're going to have a look at sort of matching those up to some graphs in these next questions. Okay, so I've got 3 of these for you to have a go at. I'd encourage you just to sort of have a look at those line equations on the right there, match it up to the ones you think, and then I'm going to very quickly go over the answers. We're going to do 3 of these just for you to have a little practice, okay? So see if you can match them up, pause the video and we'll go over the answer in a sec. Right, so the first one, we've got an x squared graph, so that is matching up to our graph A. Okay, we've got that U shape, that parabola it's called, it's our quadratic graph there. The next one we've got the x cubed. Now we've got 2 possibilities for the x cubed. We've got this wiggly one here, and we've also got this wiggly one here. So if you remember what I said about that, if we've just got the x cubed, it just crosses through the x-axis at the origin. Obviously this one over here on B crosses through at 1, 2, 3 points, and this one just crosses through on the 1 point there. So our x cubed graph from that equation is f. And for our last one, we've got our reciprocal graph, okay? We've got 2 possibilities. We've got C up here and we've got D down here. Now we've not, obviously that is very similar to the ones we were looking at, and the ones we were looking at look like this. To actually get that one C there, we'd have to have a negative x on the bottom and start sort of changing the equation up a little bit. Okay, but that's when we've got a positive value of x there, it's our graph D. Okay, so obviously they look very similar to the ones that we've drawn. We drew a graph that was basically x squared with the A. With our first one we did x squared minus 4. We very quickly looked at the actual x cubed graph when I mentioned what that looked like for F, and then our last one there for D. We literally just looked at that one there, and I actually drew that little picture when we were looking at reciprocal graphs. So there we go, there are your first 3. Let's have a look at another few little questions here. Okay, so slightly trickier looking equations. We've got some straight line graphs in this one. So have a go at matching these up. Pause the video and we'll go over the answer in a sec. Okay, so a little technique for this as well is I always do spot the ones that I like to start with, and I've straight away, I don't know why I looked at this one first, but I straight away looked at that reciprocal graph, and I know that that one's got to be that one there, so that's C for that one. C is C. The next one that seems quite obvious to me is the x squared graph. Okay, so that one's there, so that's going to be B. We've got then two linear graphs here, so we've got not a quadratic, cubic or reciprocal, but we've got linear graphs. So that question B there, if you have a look, the gradient is -2, so that's got a negative gradient, and here the gradient is +2. So obviously with a negative gradient it'll be sloping down, positive gradient it'll be sloping up. So let's just apply that logic there. So this one is going to be graph D, and this one here is our only one left, which is going to be graph A. There we go. So obviously just a little bit of a process of elimination there. Once you've got the ones that you like, then you can have a look at the ones that maybe you're not too keen on. But to be honest, those straight line equations, those linear graphs, they're actually quite nice. Let's have a look at one more then before we finish. Right, okay, so we've got our last one here. I have just noticed as I'm writing this, there was a little mistake in this one here. That last one there should have a squared, so that should be kx squared. There we go. And obviously this one looks a little bit different to normal. We've got a k in there rather than a number, and that normally just stands for a constant. It's usually used when we're looking at direct and inverse proportion, so these graphs might be referred to as being direct and inverse proportion graphs. But if you've got a k in there, it's just a constant that's throughout these questions. So it could just be, let's pick any number. The easiest is probably 1, and we'd have 1x cubed as the first one, 1x for the second one, 1 over x for the third one, and 1x squared. Now I've corrected that for that last one. Okay, so if you are going to do one of these questions, again, just don't be thrown by anything that looks a little bit different. But pause the video there, have a go, and we'll go over the answer in a sec. So the first one, we've got a cubic, so that's going to be our wiggly line one down there, so that's graph E. The second one, we've got a straight line, no squares or cubes or fractions in that one, so that's graph B. That third one there is our reciprocal graph, so that's up in the corner. There we go, so that is graph A. And our last one there, now that it's corrected to x squared, is our quadratic, and that is this one here. There we go, so graph D. Right, there we go, and that is matching up some graphs. Obviously now we've done a bit of work of actually drawing them and seeing what they look like. Now it's just about recognising them for this type of question, and obviously just doing that process of elimination if any extra or additional line equations are thrown in there. For example, for this one we could throw something in like y equals k square root of x. There we go. And actually if that one is in there, obviously we knew the other four were absolutely spot on there with our linear, quadratic, cubic and reciprocal, so that would just match up to our very last graph here, obviously as a process of elimination. So obviously if you are thrown by something, just take that approach and get the ones that you know to start with. But there we go, that's the end of that video. If that was useful, if it was helpful, please like, please comment, please subscribe, and I'll see you for the next one.